So we are going to look at the next question. The next question says the order of reactivity of alcohols to hydrogen halide is. Now the correct order of reactivity of alcohol to hydrogen halide is this. Now the general idea is that the tertiary alcohols are more reactive than secondary alcohols, which are more reactive than primary alcohol, which are more reactive than the methyl alcohol. This is the general idea. All right. So the question is the correct order for the reactivity of the alcohol to hydrogen halide is this. So tertiary to secondary, primary to methyl. That means if you want to go in the less than, it means that the methyl alcohol is less than primary, less than secondary, which is less than tertiary. So this is not correct. This is also not okay. Let's see the one that we think will be correct. This is methyl alcohol. First of all, let's eliminate anyone that does not start with methyl alcohol. So of course, you know, this one will be out. Why? Because this one does not start with methyl alcohol. This one starts with methyl alcohol, so it will be part. This one does not start with methyl alcohol. This one starts with methyl alcohol. Now, after methyl alcohol, what do you have here? This one has secondary alcohol, which is not supposed to be so. After methyl alcohol, you're supposed to, okay, you jump primary alcohol. So after methyl alcohol, they have secondary. After secondary, you now have less than tertiary here. Less than tertiary or less than primary. Less than primary. This order. Okay, this is supposed to be less than tertiary, not primary. It's a mistake because this is arrow 3 here. So yes, supposed to be arrow 3 COH. Alright, arrow 3 COH. So the correct order is this. This is methyl CH3 OH is less than the supposed to be less than primary first, but now we now have there's no primary there, so it's less than secondary, then less than tertiary. This is supposed to be the right order. All right, if you follow this one, this is methyl less than secondary, all right, less than primary, less than methyl. It's not supposed to be this way. If we want to actually take this one as the correct answer, it's supposed to be CH3. Okay, let me just check the question again so that we'll know the correct order. All right, there was actually a mistake in my typing here. Before, the correct order is supposed to be this. You have CH3 OH is less than arrow CH2 OH less than arrow 2 CHOH less than arrow 3 CHOH. Is that okay? Arrow 3 OH, arrow 3 COH rather, less than arrow 3 COH. That is the correct order for option B, and that is the correct answer to this question. Let's see the next. Which of these alcohols can be prepared from the reaction of Grignard reagent and aldehyde? Now, one thing that you should know is that I think I've answered this particular question. When Grignard reagent reacts with alcohol with aldehyde, the product of the reaction is usually a secondary alcohol. Is that okay? When Grignard reagent is what? Arrow MgX. Yeah, R is the alkyl group, Mg is magnesium, and X is a halogen, which can be bromine, chlorine, or iodine. And then aldehyde, the general formula for the aldehyde is ROC double bond OH. So when this Grignard reagent reacts, we know by rule of thumb, this arrow will attach to this carbonyl, and then this double bond here will change to OH. So we are going to have something like this. Here will be H, here will be what? R. Now, what class of alcohol is this? This is a secondary alcohol. So which of these options do you think is a secondary alcohol? Now, this alcohol has 2 hydrogen here. So this is a primary alcohol. This is not correct. Now, this one has 1 hydrogen attached to the carbon here. All right. This is a secondary alcohol. This is correct. This one here has 2 hydrogen attached to the carbon carrying the OH. This is a primary alcohol. And this one has no hydrogen attached to the carbon carrying the OH. This is a tertiary alcohol. So the correct answer is option B. These are the alcohols that are prepared by the reaction of Grignard reagent with aldehyde. By the reaction of Grignard reagent with aldehyde. All right, so let us see the next one. The functional IUPAC name for this compound. What do you think is the functional IUPAC name for this compound? I thought I've answered all these questions. Okay, let me just answer them again. Now, the functional IUPAC name of this compound, this is an ether. Now, but when we talk about the IUPAC name, IUPAC name, we are not talking about the the common name. We are talking about the systematic name. So the length here has 3 carbons. Now, because it has 3 carbons, you call it propyl group. Now, from here to here has 4 carbon. You call it butyl. So what do you think is the IUPAC name of this compound? You call it propoxy. You usually use the shortest one and then add oxy to it, and then the longest one becomes the parent compound. All right? The longest one becomes the what? The parent compound. So what do you think is the name of this compound? And it becomes propoxy, all right, butane. You can call it propoxy butane. That is the name of this compound. And that is option A, propoxy butane. Will you call it butoxine propano? You can also call it butyl propyl ether, whichever name you want to call it. But this is the common naming system. Butyl propyl ether. You arrange them in alphabetical order. All right, butyl propyl ether. All right. Now, sodium methoxide heating with bromomethane gives. Now, sodium methoxide is something like this. Sodium methoxide on heating with bromomethane we give. Now, this reaction is what we call the William ether synthesis. It's a method of synthesizing ether. Now, this sodium and this bromine will come together to form sodium bromine. Why these 2 groups here we combine, and the product of this reaction will be CHO, CH3O, CH3 plus sodium bromine. All right. So what is the name of this compound now? It becomes methoxymethane. Methoxymethane. That will be the name of the compound that will be formed. So this is sodium methoxide. This is what? Bromomethane. These 2 will condense together with the elimination of sodium bromide molecule to form an ether. To form what? An ether. Is that okay? So that is that for that question. Let's see the next. The boiling point of ether is dashed than the boiling point of alcohols of comparable molecular weight. Now, alcohols have a higher boiling point than ether. Let us check what ChatGPT has to say about that. Alcohols having a higher boiling point than ether. Let us see what ChatGPT has to say about that. Let me connect. Chat AI. Alcohols have a higher boiling point than ether. All right. So we can say that the boiling point of ether is lower than the boiling point of alcohol. Here is this sheet. Should open. Okay. So we have chat AI. Oh, I forgot that my system will not capture this part. Okay, let me check. Boiling, which have a higher boiling point. Alcohols or ethers. I forgot the system will not capture this part. To still capture the normal screen. Okay. Alcohol generally have a higher boiling point than ether of similar molecular weight. I've said that before. So the correct answer to this question would be lower than the boiling point of ether is lower than the boiling point of alcohols of comparable molecular weight. So the correct answer is option D. Now, which of the following is the least reactive functional group? Which of these functional group do you think is least reactive? Alcohols, aldehyde, ketone, ether. Which of these functional group is least reactive? Alcohols, aldehyde, ketone, in your own thinking, and ethers. Which of them do you think is least reactive among all the ones we've listed so far? Ethers are generally least reactive. Are you getting it? Ethers are generally less reactive. All right. So the correct answer to that question is ether. Option D. They are generally less reactive. The alcohol functional group is ROH. The aldehyde functional group is ROCHO. Ketone is ROCOR. The ether is ROR. These ones are generally less reactive as compared to the rest. Now, we have a question here. You use this question to answer the next question. The IUPAC name of the compound C is. Now, this is sodium 1, 2, 3, 4. Sodium butoxide, right? Combining with what? With chloroethane, all right? Or ethyl chloride to give us, what do you think is the name of this? This is ethyl chain. So this is the shortest, ethyl, all right? And then this one is butyl ring. So which of them do you think is actually comes first? Is it the butyl or the ethyl? I know the nomenclature, you use the one that comes first alphabetically. To actually name them. All right. So there's something I actually want to tell you guys. Now, when you are naming ethers, you identify the two alkyl group or aryl group attached to the oxygen, followed by the word ether. Now, the alkyl or aryl groups are listed in alphabetical order, separated by space if they are different. All right. So, if you have, let's say, dimethyl ether or diethyl ether, but in a situation where you have methyl group and ethyl group, it becomes ethyl methyl ether. That is what I was trying to tell you, that you follow alphabetical order. So the correct order here, B comes before E. So the correct answer is what? Is butyl ethyl ether. You look at the two groups, because they say the IUPAC name of the compound C is, look at the two groups attached to the oxygen. This is butyl group, this is ethyl group. It has 1, 2, 3, 4 carbon, 1, 2. So you call it butyl ethyl ether. Is that okay? Butyl ethyl ether. What is the name of the reaction above? This reaction is called the Williamson synthesis. It's called Williamson ether synthesis. Is that okay? Where sodium salt reacts with a haloalkane to form ether. Is that okay? Where the sodium salt reacts with what? Haloalkane to form ether. It's called the Williamson synthesis. All right. Now, compound A is, what is the name of compound A? Now, compound A is sodium butoxide. That is the name, sodium butoxide. Now, what class of compound is it? It is an alkoxide. It's not an alkanone, it's not an alkana, it's not an alkanol, it's an alkoxide. Now, which of the following is a distinguished test for ether? You use the Zesses test to distinguish between ethers. Right? Lucas test, no. Lucas test is used to distinguish between the primary alcohol, secondary alcohol, and tertiary alcohol. Morley's test, of course, is for carbohydrate. All right, for carbohydrate. Secondary alcohols are oxidized to, now, primary alcohols, they are oxidized to aldehyde, and then subsequently they can be oxidized to the carboxylic acid. All right, while secondary alcohols are oxidized to ketones. All right, secondary alcohols are oxidized to ketones. All right, so like I was saying, that the primary alcohols are oxidized to aldehyde. If the oxidizing agent is potent enough, it's capable of oxidizing the aldehyde to the corresponding carboxylic acid. However, the secondary alcohols are often oxidized to ketone, and there will be no further oxidation unless in extreme conditions. Is that okay? Now, the tertiary alcohols are not oxidized unless also in extreme conditions, like we said. So the secondary alcohols are oxidized to ketones. So the correct answer is option A. A very simple question, ketone. All right. The next one is, what is the IUPAC name of isopropyl alcohol? What is isopropyl alcohol? This is the structure of isopropyl alcohol. All right. This is the structure of isopropyl alcohol. And glycerol. This is the structure of glycerol. Glycerol is a trihydric alcohol. All right. Glycerol is what? A trihydric alcohol. So isopropyl alcohol is also 1. If you want to call this compound, this is 1, 2, 3. At position number 2, you have an OH. So you say 1, 2, 3. 3 carbons propane. So you say propan 2-O. Or you can say 2-propanol. So it's 2-propanol, and then this one is trihydric alcohol. You don't really call it trihydric alcohol, as I don't know why the option is like this. But if we want to call it, we can call it as propan 1,2,3 triol. Are you getting it? But it is actually a trihydric alcohol. But the correct name is supposed to be propan 1,2,3 triol for glycerol. All right. So the correct option is option A, which is propan 2-O and trihydric alcohol, and it is trihydric. Glycerol is trihydric. All right. I believe that is the end of all the questions. Thank you very much for your time. We'll see you in the next one. Have a nice day. Now, if you want to get the entire package, all the lectures on Chem 222, you can always reach me. All right. Thank you very much. You can actually reach me to get the entire lecture, the questions you expected to meet in the exam. Bye-bye.